Low back pain is a leading cause of disability in the world. There are a lot of different factors that can lead to low back pain, but it is often linked to the intervertebral disc. The intervertebral disc separates the bones of the spine, allowing different bending and twisting movements and transferring loads during different activities. The disc is made up of a gel-like centre, surrounded by lots of layers and fibres, with a layer of cartilage at the top and bottom, which attaches the disc to the bone. The general structure of the disc works as an enclosure, with the blood supply only reaching the outside edges of the disc. Because of the limited blood supply, the nutrients that reach the disc are also limited, so the disc doesn't have many cells compared to other parts of the body. The low number of cells mean that the disc may not be able to repair itself very well, which can lead to it degenerating over time. Like most tissues in the body, the cells in the disc respond to their environment. This includes both the chemical environment from nutrition and the removal of waste material, and the loads from moving and doing everyday activities like sitting, walking, bending and carrying things. However, we don't really know a lot about how the cells in the disc respond to these different loads. Biomedical engineers at the University of Exeter are building a new test system that will be able to simulate the loads that act on the intervertebral disc during a range of daily activities, while keeping the cells in the disc alive in a culture system. This will help us to understand how the cells in the disc respond to different activities, understand if certain activities may improve disc health or increase the rate of degeneration. And it will also provide a way to test whether new treatments, such as regenerative therapies, are effective. This research is being completed in the Department of Engineering, with support from researchers at the University of Queensland, and is funded by the Engineering and Physical Sciences Research Council.